All right, we're recording now. We're going to learn about the frictions ramp lab, and we're going to ignore that I've even talked already so that all of this gets recorded. Thank you for reminding me. So we're going to calculate the coefficient of static friction and the coefficient of kinetic friction for two different objects. So you need two different objects, okay? One of them, try to pick one that's stickier than the other, that has a little bit more friction. You don't want something like super, super sticky, like don't use tape, but something that you think is more, that slides easier than the other one, okay? Then you need a protractor or a phone with the level app. Now, I would suggest using the phone. What you need is the measure app. It looks like this right here, okay? This measure app, um, can I move it around for you? Look at this. This measure app, this is what it looks like. Um, it doesn't work for the iPad, but on the iPhone, there is a little level thing at the bottom. And if you click the level thing, your your iPhone now turns into a nice, beautiful level. And it's fantastic. Okay. So you can use this. You need to use this. If you don't have an iPhone, I'm sure Android has some type of app that you can do this. And if you don't have any technology, then you can, I don't know how you're talking to me right now, but you can just use a protractor. It's just going to be a little bit harder. Okay. You need a meter stick, timer, iPhone stopwatch, totally cool, tape, and probably a helping hand. You could use books to prop stuff up for you, but you probably want someone else to help you. It'll just be easier. Okay. So the procedure. What are we doing? There's two different parts to this lab. There is the static friction, and then there's the kinetic friction. Okay. Both of them are independent of each other. So let's go over to my setup over here. Okay. My assistant is ready. He's ready to help me out. Okay. How can I set this up that you can see? Okay. There we go. Cool. So you need a table. I would suggest using a table that is hi, Hobbs. Using a table that is light because you are going to need to pick it up. So what I have here is just my crappy little IKEA coffee table that I stole from my brother. It's very lightweight. It's very, very nice. If you don't have a nice table like that, you can do this with a ramp. It's kind of similar to what you did with the other question, or with the other lab, but you probably want it to be a lot longer. Like this is a good length because you're going to be timing objects moving across it, not across a flat surface like the other one. So you probably want, hi buddy, a little bit of a longer ramp. If you want to lift up your dining room table and your family's okay with that, go for it. But like I said, smaller table, probably easier. Okay. So what you're going to do, take your phone on the level app. Okay. And you are going to put it on the table like so. Okay. Great. I don't know if you can see that, but it's green. Okay. That means it's level. And as I move the table up, notice it tells me what angle the table is at. Okay, put it back down, it goes green at 0. It's beautiful, okay? So you need to take everything off the table because you're gonna be lifting it up and stuff's gonna slide around. So take everything off, okay? Now, you need two objects, like I said. I'm gonna use a Kleenex box and Hobbs's rubber tire, okay? He's also just watching the neighborhood dog walk by. So he's having fun right now. Hey, are we safe now, Hobbs? Hey, we're safe? Okay, good. We're safe. Don't worry. He took care of it. So these are my two objects, Kleenex box and this rubber tire. Okay. So you're going to take object one. You're going to put it on the table. And then you are going to slowly lift up the table. Da, 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 watch the app. And as soon as the Kleenex box starts to slide, right there, record the angle. Okay. Just as it starts to slide. You're not timing it sliding across anything. You're not measuring anything. It's just as it falls across the table, okay? You are going to record that under the static friction, okay? Oh no, my screen's frozen. Give me a second. So you are going to record that under this first static friction data table, okay? So this first object, okay, this was a Kleenex box. The next one is a tire, okay? Trial 1, angle for the Kleenex box. I wasn't actually looking at it. Let's just say it was 18 degrees, okay? You do it 5 times, beautiful, find the average. Then you do exactly the same thing, except with your other object. So take the table, lift it up, watching that, watching your phone, okay? There we go, we're at 17 degrees, there we go. What's gonna go first, my phone or the tire? Oh my goodness. Okay, I'm gonna stop there because I don't want my phone to go sliding on the ground. This is where a helping hand is good. I have a leather case on my phone, so it is kind of sticky, so it probably would be okay. But maybe you want to put a piece of tape, or you just want someone else just to hold onto the phone so that it doesn't go anywhere. Okay. And the objects that you pick stuff that you're okay with slamming on the ground because they will hit the ground. Don't use your phone because if your phone breaks and hits the ground, it's not my fault. Okay. So do it for the 2 objects, fill out the table, and you have your 2 averages and you're good. Okay. That's procedure number 1. Procedure number 2, kinetic friction. Okay. This one is slightly more involved. Okay. Again, clear the object, all that stuff. Now you need to make a mark on the table. Okay. This is where tape or pencil, whatever you want. I don't have actually tape with me over here. What can I use? Oh, here's a pencil. Okay. So very similar to the last one, just make a mark at the top of your table. Okay. Let's say right there. Okay. I'm just drawing on my table. There's the starting point. And then you are going to measure a distance probably to the far end of the table here, and then you are going to measure that distance, okay, so that you know exactly how far your object is sliding off the table, okay. Now you need to lift up your table and set it at an angle. I think 35 degrees is pretty good. Okay, so that's where textbooks or pillows, I'm just going to take the pillow from the couch. That's where a table or a textbook or something or another person comes in handy, because all you're going to do is set your table at an angle and leave it there. Okay, so right now this is only a 10-degree angle because I'm just using a pillow. You don't necessarily have to use 35 degrees, okay? So I'll make a note of this, right? This doesn't have to be 35 degrees, but it must be bigger than your angles from part A. Okay, because if it's not bigger than your angles from part A, your objects aren't going to slide. So you don't necessarily need 35 degrees, but it needs to be bigger than that. Okay, like this tire, we got to like 20 some degrees and it still wasn't moving, so my angle needs to probably be 25-30 degrees. Okay, once you set it there, leave your table, your angle. You only need your phone on here for the first part. Set the angle, then don't touch your table. Okay, but now you are going to take your objects, put them at the starting point. I'll move you a little bit over here. Okay, put them at the starting point here. This isn't even steep enough for my Kleenex box to slide down, so let me make this more. Here we go. Sure, that's more steep. There we go. Let the Kleenex box. Okay, see how it moves, but like not really. Okay, you don't want that. You want nice motion as it slides down. You don't want super fast motion. This is a terrible ramp, but you want nice Look at that acceleration down the ramp. Isn't it beautiful? And you are going to time how long it takes your object to slide from your starting point down the ramp to the ending point, okay? And you're going to record that in the kinetic friction data table, okay? So you put your distance here once. This is your table distance, or just the marks on your table. Again, the same objects, use the same one, same. Record the time 5 times, get the average, okay? Now, record, if you decided to use a different angle, record your angle, okay? If you didn't use 35 degrees, make sure you record that angle there so that you know what angle you're at, okay? Just so you don't forget, 35 is a nice angle. It's steep, but it's not too steep. But to be totally honest with you, this right now is 21 degrees. This is what it looks like from a distance. So I don't know. It's steep, but it's not that steep. Okay. Cool. So now that's it. Taking data for this, relatively easy. Okay. That's the experiment. Lots of fun. Okay. Any questions about the experiment? About how to record data, any little things about it? Okay, if you think of some, let me know. We're going to look at how we analyze this data now. Okay, so to analyze this data, we have to do 2 different things. Okay, first one for static friction. Okay, we are going to again draw a free body diagram. That's no problem. Write the sum of the force equations. That's no problem. Now you need to solve for your coefficient of static friction. Okay. Now, there's a little mathematical trick here that some of you do not know. Okay, actually, most of you probably don't know this, but I'm going to help you out a little bit. Okay, there are these things in math called trig identities. Okay, a trig identity. Okay, this is grade 12. I'm not going to lie. You do a full unit on trig identities. They're fantastic in math. It's great. Okay, but we're not going to do any fancy trig identities. The one trig identity that I'm going to tell you is that if you take the sine of any angle theta, is my screen frozen or can I just not see it? Oh, no, it's good. Okay. If you take the sine of theta of any angle and you divide it by the cos of that same angle, what that equals is the tan of that angle. Okay. Tan is sine over cos. So what that means, as a little hint here, okay, this is a very, very strong hint where if you have something that looks like this, let's say 10 sine theta equals 5 cos theta, we don't know how to solve that because there's 2 different angles, right? Oops. There are 2 different angles here, one there and one there. So we don't know how to solve it. So instead, what we have to do is if we divide both sides by the cosine of theta, okay, we can cancel out our cosine theta and we can rewrite what's left as 10 times the tan of theta equal to 5. Now we can solve this tan theta equals 5 over 10, take the inverse, and now away we go. Okay, but we don't know, up till now, we don't know how to solve anything that has sine and cos in it, but I just taught you. Okay, this, I'm telling you right now, you will need to do this. If you don't do it, then you did it wrong. Okay. I'm not going to lie. You can look up, if you're confused, you can look up this, like, this is a pretty common lab to do. This is a pretty common thing. If you look up finding the coefficient of static friction on an inclined plane, you'll get videos of this showing you what to do. It's actually a very, very nice solution. This simplifies down really, really nicely. But you have to use this little trick. Okay. So you're going to do that, and you're going to use your average angle. You're going to solve for the coefficient of friction, static friction for object 1 and object 2. Okay, cool. Kinetic friction, a little bit nicer. Same thing, free body diagram, object on an incline, you know, the beautiful stuff like that, la, 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 I don't know, something like that. Write your sum of the force equations, make sure you have your sum of the forces in the parallel direction, sum of the forces in the perpendicular direction. You guys know how to do that now. Then you're going to solve for your acceleration. Okay, solve for your accelerations for both objects. Okay, you need to do both objects, because they are not going to be the same. These things are going to slide at different rates. So they're not the same. They are not the same. Okay, and once you found your acceleration, you can now go back to your net force equation, use your acceleration, and you can solve for the coefficient of friction. Okay, this part 2 here, you are using your distance and your average time. So this part is actually kinematics, right? Think about you're starting from rest, you measured a distance, it slides for a time. You can use that to solve for the acceleration. Then take the acceleration and plug it in for part 3 when you use dynamics. Okay? And again, solve for both of them. Okay, object 1 and object 2, put it at the bottom. Okay? Couple things here when you're doing this. Once you've done it, you should know, right? Kinetic friction should be lower than static friction. Okay? So this number up here, your static friction, should be bigger than your kinetic friction. Okay? They should also be decimals. If you get like a coefficient of like 3, you did it wrong. So make sure that those are decimals. Okay? And yeah, and you can also double check, because you're picking an object that is, one's more sticky than the other, right? One has more friction than the other. You should expect, like for me, I did a Kleenex box and I did a rubber tire. Okay, which one do you think has more friction? Right? Let's say this Kleenex box might be 0.10 and this rubber tire might be 0.4. Okay, that makes sense. I'm happy about that because the rubber is higher than the Kleenex, which makes sense. Okay, so make sure you're thinking critically about your results. Did you actually get something that makes sense? Okay, cool. And of course, after you've done the calculations, there are a couple discussion questions here. Compare your two frictions. I literally just gave you the answer. Why do we do multiple trials? How could you have decreased the coefficient of friction between your object and the surface? And did your results agree with the prior knowledge? Like I just said, right, you should expect rubber would have a higher coefficient than wood. Okay, cool. And that is the lab. Okay, does anybody have any questions? Did I go too fast? Does it make sense? Doesn't seem too bad. We're all good. No, nothing. Okay, good question. Does the distance of your table matter? Um, no, but yes. Okay, no, but yes. And why it matters is because you are timing this. Okay, so the first thing that really matters is that you have a nice, smooth acceleration. Oh, you couldn't even see that, right? You need a nice, smooth acceleration like that. If it's too slow, like if how I had my table before, if this is too slow and you kind of have to like push it to get going and it slides a little bit and it stops, that's not good. Okay, you want nice, constant motion. Okay, but too fast, like if I put my table up like this and I go, pew, yeah, that's nice, smooth motion, but that time, the distance that it's traveling, because it's moving so fast and you're timing it from here to here, your reaction time of stopping it is not there's going to be way too much error there. So you want to find that balance based on whatever materials you have available to you. Find that balance where you don't have kind of choppy motion like this. You don't have super steep fast motion. You have a nice kind of smooth motion with a time that you can very easily time. As a general rule of thumb, I like to, when you time things like with your iPhone like that, I want to keep things around 1 second, because 1 second is long enough that that the error of your reaction is not going to be a huge impact on it. If you're trying to time things that are like 0.1, 0.2 of a second, your error is way too big. You know that from the reaction time lab, that you just have like there's just too much error there. Your results are going to be all messed up. So I hope that answers your question. The distance of your table does not matter, but too short, you're not going to have a long enough time to time. But maybe a shorter table, you have a slower moving object. It's totally up to you. Okay. And this is going to be due tomorrow. I want you to get this done before the test. Just because it's good practice for the test. This is essentially a dynamics question, that's all it is. It's good practice for the test, so I want you to get it done before the test. When I send it out on CrowdMark in a few minutes, it will be, I'll put a due date of 11 a.m. tomorrow. Yeah. And so with the CrowdMark, I will put oh, my iPad's over here. I will put, of course it's for, my iPad always, it's like if you don't touch it for a while, it freezes. There. Good. Really? Why is it still frozen? Oh no, there we go. So on CrowdMark, I don't need this first page. I need this second page, and I need this third page. So I will put kind of like page 1, page 2, something like that for you to put your answers on. The discussion questions, I don't know if CrowdMark lets me do a written response. I have to play around with that a little bit. If it doesn't, either you can type it up and just send a picture of it. You can write it out on paper, as long as it's neat, and take a picture of it. It doesn't matter. Okay. But I will have those instructions in CrowdMark once it gets sent out.